now. Okay, so the first thing we're going to do is going to simplify fractions. So for example, let's do a simple one. 12 x to the third, y to the fourth, over 15 x to the second, y to the 10th.
Is this a review?
Yes.
Perfect. Thank you for by the way posting that.
So 12 over 15, we could reduce this by taking out 3 out of them. So 4 over 5. X third divided by x second. There's an x left over on top. And in this case, y4, y10. There's 6 y's left on bottom.
No, I thought you put on.
You could put y to the negative 6 on top and then just put it on the bottom later. In that case, I removed everything I needed to. So that's as simple as possible.
That's it.
For this question, yes.
Don't be I forgot.
So x plus 2, x minus 4, over x squared, x plus 2 squared, x plus 4.
So can you cross out the x plus 2's but one?
So in this situation, I'll let you guys copy it down.
Squared, so that means it would keep would you keep one of the x another x plus 2 just on the bottom?
So just like the x's, like x over x squared, that would mean there's a 1x left over on the bottom. In this situation, x plus 2 to the 1 power, x plus 2 to the second power, it's the same situation. It's not x at time, it's x plus 2, but there's still going to be 1 left over on the bottom. So x plus 2 to the 1 power. There's nothing here, so to the 1 power. Yeah. Now, x minus 4, x plus 4, are those the same thing? No. So you cannot cancel those. So x minus 4 on top, x plus 4 on bottom. This is as simple as this one could be.
Which one did you cancel on top?
So I end up canceling this x and reduce this to 1. And this one and reduce this to 1.
Wow, recorded.
This is recording, yes.
Wait.
I'm not going. I'll put it on this side so he's still up here. Okay. I'll keep it up here actually. You got it? No. So x squared plus 6x plus 5 over x squared plus 4x plus 3.
Cross out the x squared. No.
In this situation,
You're not recording?
I am recording. In this scenario, you have x squared plus 6x plus 5. That's 1 unit. You cannot just remove the x squares. The same way I cannot reduce the 6 over 4 into 3 over 2. They're technically within their own parentheses, but I don't need to draw the parentheses.
Just 2x. 2x2.
So in this situation, I'm going to have to factor them. I can only eliminate it if they're multiples to each other.
What do you mean?
For example, let's use a real number as an example. 15 over 12. We did it earlier. That's 5 over 4. We all agree on that. That's because 15 is 5 times 3 and 12 is 4 times 3. Because they're multiplied to each other, you could cross them out. I can't do, if this was 15 over 12, I'm not allowed to write it as like 10 plus 5 over 10 plus 2, cancel out the 10s and get 5 over 2. That would be completely wrong. Same thing with variables. So over here, I'm going to factor the top. This one was already factored. This one we're going to have to factor.
Bring it down, so I can see 2x2.
It's not multiple.
Talking about?
So I factored this into 2 separate things that multiply to each other. Once they're written in terms of multiplication, then I can cancel out. So what could I cancel out here? The x plus 1s. Then what's left over? X plus 5 over x plus 3. It was the 3 on the bottom, right? 3 and 1 adds to 4.
Were you listening in on our our conversations.
I heard Rahel say she'll do better on the test.
So, well, I know it's on video, so if you just comment on your nice shave real quick.
Yeah.
My shave is very nice, thank you.
Nice.
Hair guy, he decided to donate some hair to.
I don't think they want beard shavings.
So, thoughts on
I feel bad for anyone's wig that's come out of the beard.
So, thoughts on Arnie's new cut?
It's a change. Not right now.
Real ones remember it with the short hair.
Real ones.
I remember from like second grade. Like, I'll never forget. It's small. Alright, let's continue.
Yeah, okay.
Shut up.
So for this one, you can multiply two fractions. So for example, x squared plus 4x plus 5 over x squared minus 25 times. This would be all the same section because the sections were very big.
What's the
Yeah.
section?
There was like 3 sections.
What's on the test? What's on the test?
This is the
5 point. I said it on the thing. I forgot to put this. Yeah,
5.2.
4 to
This is
5.6.
the hardest, right?
No, the plus thing I think is harder. So this one and this one. Let's do x squared plus, yes, plus 2 over x
So, we'll make the fraction.
plus 1.
Oh, got it.
All right. So when you multiply two fractions, luckily you don't have to do anything. They just multiply next to each other. So the first thing I would do if I was solving
You
this,
have to get the same box.
that's if you're adding them, which is the harder part.
Oh.
So this one, I'm going to factor the top left. So that's x plus, oh wait, I have to fix this. It should be 6.
Wait, what's the 6?
The middle of this one, because then it would work. X plus 5, x plus 1. The factors of x squared minus 25 is x minus 5, x plus 5 times. Over here, x plus 2, x plus 1.
You have to factor it out first, then multiply.
You factor out first. I recommend doing that.
Wait, what's it say on the bottom?
Because then
What's it say on the bottom? Plus 1?
x plus 1, just the same thing. There's nothing to factor, so I just keep it.
Okay, just multiply first.
You don't want to multiply first because you would have to do a super foil, then do super factoring, which is definitely not right.
Are you able to like cancel the x plus 5?
So, because you factored it out, you're able to cancel things early. So, x plus 5, x plus 5. You have 2 x plus 1s on top. Make sure you only cross off one of them if you're going to cancel them out early, okay? You can't cross off both of them. So, I'm going to rewrite it as x plus 2.
Wait, why did you cancel the x plus 1 on top of that?
Why did I not cancel the x plus 1 on the right? Because I canceled the one on the left.
Could you do it not cancel out x plus 1 out?
Sure, but then I would cancel this one instead.
Yeah, but I'm saying that it's
It doesn't matter which order you do it now. You still will have an x plus 1 in your final answer. Can I cancel anything else looking at this? I'm happy with that.
that's all you do. So why did
For that one.
so why were you teaching us like such complicated stuff? Wait, no.
You're not
One problem with them like it's so many extended like
when we're like multiplying it too? Like,
Sherelle, to answer your question, questions get harder as you go on to the section. And Gullet, what was your question?
Any of those
Or
questions
Gal?
are going to be on the test.
I don't know how to answer that.
wait, so could you do like one of those questions?
Yeah. Why would I review it if I wasn't going to do it?
I don't know, like I feel like you're
I'm sorry, do you not? You can watch somebody else's video then, and then hopefully that will help you for your test. Dal, what's up?
so, how come there was like examples before, like maybe not in this lesson, but later on, are like, what would I have to like foil it and do cross multiplication? What do I have to like foil it if I'm multiplying?
Hmm.
At least how multiple we're talking about?
Say that again?
There's an example I remember in one of the recent homework where you have to like foil.
Cross multiply is when you have an equal sign in between everything.
Something when you have to foil it, it's like multiplying it.
Oh, that's when we add and subtract, so wait for that.
and like that was like all
I mean, this is how it's going to be given to you in the question. So, what is going to be here?
Is this a new problem?
Yeah, new problem. So, little different with this question. There's a division symbol in between. Because there's a division symbol, we are dividing a fraction. So when you divide a fraction, you could rewrite it as a multiplication of the reciprocal. So x squared plus 3x plus 2 over x squared minus 1 times the reciprocal, x squared plus x minus 1, or minus 2, my bad, over x plus 2. From there, you could rewrite it. Or you could factor it now. The top left one, x plus 2, x plus 1. The bottom one, x minus 1, x plus 1. The top right one, x plus 2, x minus 1. And the bottom one, x plus 2.
When you cross over,
When there's an equal sign in between.
when there's division, you just flip the sign.
Then multiply. So it's a multiplication equation with one step before it. Okay, now we cross out anything in common. X plus 1, x plus 1. I see x minus 1 and x minus 1, and x plus 2. Again, it doesn't matter which one you cross off. I'll cross off this one, but it's an x plus 2.
Oh, wait, you can cross out like across them if they don't.
Yes, you could cross off a cross.
Wait, I gotta write that out.
Okay.
Wait, you can cross them across?
Yes, like a x minus 1 here and x minus 1 here can be crossed out.
No, look, 'cause it's.
He's saying cross the multiplication
They
side.
don't have to be on top or bottom of each other.
Oh, I meant like. No, I was talking about. I was thinking like.
Remember, when you multiply, you make it one big fraction anyway, so it doesn't
Right,
matter.
But like, let's say suppose it was like, I don't know, an x plus 1 here. Would I be able to cancel this and this out? No.
No, not. I see. He means diagonal. He means diagonal.
Okay,
Yeah.
fine, whatever.
So x plus 2 is the only thing left over. So that's your answer. X plus 2.
Wait, the x minus 1 for the bottom left one?
X minus 1, which was here. X minus 1, which was here.
Wait, x minus 1, x plus 1?
The bottom's x minus 1, x plus 1, yeah. Because of the difference of squares.
Alright, fine, so.
I know we were like a time ago. They don't have this off our mat. It was already there.
Is that it for that section? Pretty much. Okay. Next section.
That was 5.4.
That was 5.4. So 5.5, adding and subtracting. So let's start with our basic one. 3 over x plus 4 over 5. Guys, shh, we're on our next one. So 3 over x plus 4 over 5.
Oh, I need
So I need the denominators to be the same.
so 5 over.
So I would like the denominators to be the same thing. Guys, shh.
1 over 5.
Hold up. Guys, I don't want to overtalk over people again. So in this case, we're going to multiply this by 5 over 5 with our goal to making the bottom over here 5x. And we're going to multiply this by x over x with our goal to make this 5x.
What is x over x?
Is 1.
Okay, fine.
5 over 5 is also 1. That's why we're allowed to do it, because we're not changing the value of it.
Why can't
We're,
you multiply 1 over 1?
you could, but that doesn't solve your problem, which is change the base of the same thing. So 5 times 3 is 15 over 5x plus 4 times x is 4x over 5x. Wait a second.
Cross out the bottom.
No. This is not equal to anything, so then we're just going to combine this. So 15 plus 4x equals 5x.
Why would it be 10x?
You don't add the denominators when you add fractions.
Can you do 15 divided by 5?
You could, but you get back to here, which is the problem, though. I need these to be the same. My goal to doing anything here was to make them the same. Go.
I know you want to use this one, but isn't also 15 plus 0.8x correct as well?
No, it would be 15 over 5x plus 0.8x if you're going to simplify that. Because you would have to do, this is 0.8x. No, write it how I wrote it, actually. I'm not going to entertain that. Actually do it the way I did it. No decimal.
Let me guess, because 15 and 4x is like 1 unit.
Yes. Okay. Another one. Guys. 4 over 3x squared plus 6x minus 2x over 3. No. Over, say 9. Okay. Guys, for this problem, we need a common denominator again because we're adding or subtracting fractions. This one's tougher because the common denominator is harder to find. So what I'm going to do is rewrite this as its own thing. You will eventually do that, but it's not obvious what to do. So let's figure out how to do it, or how to find a number and multiply on both sides. So in this case, I wrote 3x squared plus 6x, which is the denominator on the left, and 9. So I'm going to split 9 into 3 and 3. So 3 times 3. How can I factor this? What can I take out in common?
3x, parentheses, x plus 2.
I could take out a 3x, which leaves over an x plus 2. So over here, x plus 2. So do they have anything in common? The only thing they have in common is a factor of 3, like a multiple of 3. Which means we have to multiply what's not in common to the other side. So on the left side,
X is its own unit. You can't do that.
no, 3 times x is not their own unit. 3 plus x is its own unit. So over here, this right side has a 3 that this left side's missing. So I'm going to multiply 3 over 3 here. While over here, this side's missing an x and an x plus 2. To make it easier, I'm going to multiply x squared plus 2x. You're not getting the simplest fraction.
You don't make that a fraction?
No, what she said, can I just multiply this whole thing to the right side, the whole thing to the left side?
Like I'm saying is x squared plus 2x a fraction over x squared plus 2x.
Yeah, fraction. So this is going to be 12 over 9x squared plus 18x minus 2x to the third plus 4x squared over 9x squared plus 2x. 18x, thank you. Does the bottoms match? Because the bottoms match, I could combine like terms. This negative is technically distributed to here and here. So I'm going to write...
How would I know that?
It's a minus, so you just have to know minusing multiple things. 2x third minus 4x squared. None of these values combine, so no worry there. Over 9x squared plus 18x.
Wait, why is it negative? Why would it be both?
You distribute a negative because there's like a visible parentheses here. I'm subtracting this.
Is that it? Total
You could just use subtraction also, but you cannot actually combine these terms. They're not like terms. That's it for this one.
So I have to hold it. So I have to write it. Oh, I thought.
No, no.
Why is it 12 minus 2x plus? Why is it not plus 4x?
It's a negative that has to be distributed. Or you're minusing the whole thing, which means both parts are subtracted.
Okay, fine. So I have to write a negative basically for the.
Yeah, you got to make sure you distribute it correctly. Yeah. It was a 2 in the front, you distribute a 2 to everything. Was there anything else in this section? Yeah, so the key skill here is to get the common denominator, okay? If you can't get the common denominator, you can't do this section of the test, nor the next section of the test. Yeah, you will likely fail. All right, next one. Yeah. This is 5.6, or what is our last section? 5.6 is equations. So first off, we'll get simple fractional equations. 3 over x equals 2 over 3. You're going to cross multiply in this situation. Now this is 5.6.
But can you do 3 over 2?
You could do it like that too, I guess, yeah. That's definitely worse, so don't do it like that. Because that's simple here, but it's going to be equations later. So this is going to be 9 equals 2x. Divided by 2 on both sides. X equals 9 over 2. Straightforward question there to start off the section, and then we get the harder ones as we go on.
This is just lengthy, isn't it?
X plus 2 equals 4 over x minus 1.
Oh! I didn't say we're doing a review. I was like, well, why are you saying we're doing a review? Where's the pencil? That's what we did a review.
So this one, we're going to cross multiply again. We cross multiply because there's an equal sign in the middle. So 3, x minus 1, equals 4, x plus 2. When you distribute, yeah. So it's going to be 3x minus 3 equals 4x plus 8. No, you're right. I'll just... Remember, in this situation, I like to move the smallest x. Minus 3x, minus 3x. Negative 3 equals x plus 8. Subtract 8, subtract 8. Negative 11 equals x.
Does it matter?
What's up?
It doesn't matter. X equals 11, negative 11.
It's x equals negative 11. 11 and negative 11 are different numbers. So those are the simple ones where you just cross multiply. Sometimes we have situations like this. 3 over x. Oh, sure, I'll write it over here. 3 over x over 5 over 4 equals 7 over 2x. We need a common denominator with all three things.
Wait, so what did you do last problem?
You could do that, but it's not guaranteed that what you result in cross multiplying. In this one, it would be possible. But in like a more complicated question, what you cross multiply and factor to might not be factorable by hand. So this is why I recommend just doing all of them matching.
So why did you do last problem? Common denominator last problem.
Because there was no plus or minuses there.
Oh, so no plus or minus. No, no plus
Now you need to make everything a common denominator. The only reason we want common denominators is to plus or minus. So I have an x, I have a 4, and I have a 2x.
That's so funny.
This 4 can be broken down by 2 and 2. There's nothing all three have in common. So what is the smallest thing all three things can multiply to? 4. This is 4. The smallest thing they all can multiply to is 4x. The smallest thing they all can multiply to is 4x. Which means the first thing is missing a 4. This thing is missing an x. And this thing is missing a 2. It already has an x, it already has a 2, it just needs another 2. So that means I'm multiplying this one by 4 over 4. I'm multiplying this one by x over x. And I'm multiplying this one by 2 over 2. Which means I have 12 over 4x plus 5x over 4x equals 14 over 4x. 7 times 2 is. 7 times 2 is.
Oh, you multiply that, but you broke it down.
Wait a second. They all have the same denominator. Which means, since they all match denominators, I could cross them all out.
Wait, why can you cross them out now? Because it's equal sign?
Equal sign, yes.
Yeah, I'm
So then, I'm going to rewrite it as 12 plus 5x equals 14. Now we got algebra 1 going on. X equals 2 over 5. Subtract 12 on both sides, divide by 5.
You can only cross out the denominator.
Yes. Hmm.
I did this. I added this. I kept the denominators. So I did 12 plus 5x equals 14. I crossed
20 divided by 6 is...
Isn't it? Wait, why 6? Don't I do the other side?
What is this, x squared?
Yeah, because I did.
Why is this x squared?
Because I cross multiplied.
14 times 4x is not x squared. Why is it?
I got this here.
Oh.
20x.
Why is this
squared.
x squared?
I didn't. I got the result because I foiled, right? It's,
No. Why is this x squared? It was not x squared before. It's
I did
2x.
square. It's 4x. It's 4x.
Then how did this become 20x squared?
I'll show you. Look. Here. I cross multiply, right? So I did 12 plus 5x equals 4x. I mean, this is what you get your foil, right? So I did this to this.
Okay.
20x squared plus 48x, right? Then here is 56x, right?
Yeah, so subtract, I would subtract 56 to here to set it equals 0, then factor and solve. The thing is, that's harder. I'm telling you the easier way to do it.
What did you do?
I made them all the same, not just half the.
All denominators the same. I'm gonna cross.
Yes.
Are you done with
Yes.
your review?
No. All right, another one. 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. Yes. Ask them.
Why do you with the easy part?
All right. Shh. I wrote the denominator separate, and then I factored x squared minus 9 as x plus 9, x minus 9.
And together, and this is the port.
Guys, can you do your project anywhere else? Shh, I can't. So, in this case, this is
Well, I don't think that was your excuse, Tony.
X plus 3, X plus 3. This one already has X plus 3, X minus 3. Doesn't need anything. This one needs an X minus 3 over X minus 3. So I'm going to rewrite this as 6X plus 18 over X squared minus 9 equals 8X squared, X squared minus 9, minus 4X squared. This one? The middle's nothing because it's already good enough. Like it's already at the point of the same. Like I don't need to change it to make it the same.
Like minimal. Like you like yell at us and
All right. In this one, we have X squared minus 9 on bottom. Cross them out. Remember, this is minus, so make sure you go to distribute that negative correctly. So 6X plus 18. To the right side, yeah. This is the thing that's being subtracted, so.
That whole thing is negative then? 4x minus what?
But this is double negative, so plus 12x. I'm dealing with x squared and x. So what I'm going to have to do is to set it equal to 0. So I'm going to subtract 6x on both sides and minus 18 on both sides. Yeah, what's up?
It's not about this. It's about what size do you take?
What?
What size is 12 do you take?
You don't have to take that.
Yeah, I don't think you have to.
But don't you not take math?
You have to. You don't. You could opt out being math, but that's definitely not good for your college thing.
Okay, I'm going to start on math.
So 4x squared plus 6x minus 18. Is there anything in common I can factor out to make my life a little easier? A 2. Because I could divide everything by a 2, including this side, I don't need that 2 anymore. Like the 2 I'm factoring out. So it's just 0 equals 2x squared plus 3x minus 9. Now I have to slide and divide. So I take the 2, bring it to the negative 9. Minus 18. Then things that multiply to 18 to add to 3. Negative 18 to add to 3. Good. X plus 6. X minus 3. So then, remember, I borrow a 2, so I have to pay back a 2.
My class is like Kirsch,
This is X plus 3. Move the 2 to the front. 2x minus 3 equals 0. You split and solve.
Why do you just forget about the 12x?
12x. 12x minus 6x became 6x.
Okay. Why did you do the 2x?
Is this the last unit on the test?
The one more after this.
What? You said this is the last.
Or one more type of problem on the
Why'd
test.
you move the 2?
After this.
These problems are so long.
That's how the factor slide to divide is. The slide to divide, you have to bring it back. Now, very important thing. You have to check for extraneous solutions. In this case, negative 3, if I plugged it in here, what would happen? It would cause the bottom of a fraction to be 0. If it causes the bottom of a fraction to be 0, it's not a valid answer. So make sure you cross that out or indicate that's not an answer. Your only answer that's acceptable is 3 over 2 in this case. Remember, you check by just checking if it causes a 0 on the bottom. Negative 3 will cause a 0 on the bottom.
I thought you just divided by 2. I thought you don't multiply by 2.
This one simplifies, so you could do. If you can't simplify, you move it to the front.
These problems are long.
All right, last one. I think I'm running out of time, so I gotta go quick. Very quickly. Fractions and fractions, we call that complex fractions. Thank you. Fractions and fractions, we call that complex fractions. So for example, let me zoom. Yeah. I didn't realize I didn't post it. That's my fault. So let's do x over 6 plus 2 over x over 3 minus 1 over x.
CBC's going crazy.
Okay. All right. So in this case, we have a complex fraction. So the first thing I do, I make everything a fraction. So I'm going to rewrite this 2 as a 2 over 1, okay? You could put like an under 1 right in there. Now in this situation, I want all my denominators to match. So I need 6, 1, 3, and x to match. What's the thing that they all can multiply to? First deal with the numbers, which is 6, then deal with the variables. This has an x, so it needs an x. So your goal is to make everything into 6x. First deal with numbers, then with variables. So for each fraction, you need to give it what it needs to reach 6x. This is already 6, so it needs an x, so x over x.
Wait, on both top and bottom, or just
On everything, yes. I'm teaching it the easiest way, which is do everything. So then, over here, this is a 1. So what does it need to get to 6x? 6x. Over here, this is just a 3. So what does it need to get to 6x? A 2x. And over here, it's just an x, so it needs a 6. So it's x squared over 6x plus 12x over 6x over 2x squared over 6x minus 6 over 6x. Because everything has a 6x on the bottom, I could cross them out. So I just rewrite this as x squared plus 12x over 2x squared minus 6. That's it.
Are you ending it?
I'm recording.